Another little blurb, you get the same general problem that asks you to do this, is you note that y equals log base 2 of x equals log of x over log of 2. I'm using the log log, which is the base 10 log. So we don't have to write the 10 if we're doing the log log, but I'm going to do it anyway. Okay, so we have log base 10, log base 2 of x equals log base 10 of x over log base 10 of 2, which tells us then that log base 10 of x is log base 10 of 2 times log base 2 of x. So that if we want a graph of the base 10 log, we just multiply the base 2 log values by 0.3, by the log base 10 of 2, which is about 0.3. So this is approximately 0.3 times the log base 2 of x. So now if we want a log base 10 of x, I can relabel the axes here, and what I get is a relabeling of the y-axis. I don't have to relabel the x-axis. Since I'm multiplying all my y values now by 0.3, that's what I do here. 0.3 times negative 2 is negative 0.6. 0.3 times negative 1 is negative 0.3. 0.3 times 0, of course, is 0. 0.3 times 1 is 0.3. 0.3 times 2 is 0.6. So there I have my log base 10 values. And if I read the scale here, this tells me that the log base 10 of 3 looks to be somewhere between 1 and 2, probably a little closer to 1. I'm sorry, that's a log base 2 of 3. Now, this means that the log base 10 of 3 is going to be between 0.3 and 0.6, and probably a little closer to 0.3, maybe about 0.42 or something like that. Okay, so we could estimate our log 10 values from a graph of this nature. Okay, now usually you're going to use your calculator, but you should be able to make these estimates, and that's one thing that I'm going to ask you to do in the problems. And another part of that is going to be, okay, we're going to go ahead and extend this out to 8. So if we keep going, 8 is going to occur about here, and 3 on this axis will occur about here. So that's going to give us a point maybe about here. And then we can fudge a little bit. We don't want to go all the way out to 16, we could. But we could go a couple more units and get to 10. And then we could relabel 3 as 0.9. And it turns out that the log base 10 of 10 is 1. So we can kind of complete a table for log base 10 just based on the log base 2 graph and this approximation. And we get a pretty good approximation to the base 10 log, and it turns out that this is about all we need to know in order to determine base 10 logs of just about any number. You'll see more about this in the problems.